Well, I just realized that since the power supply is on a separate chassis and it's disconnected from the main TV chassis, there's actually nothing connected to the two sections on the one capacitor, one original cap that's still in there. So let's see how healthy it might be. We've got a 20 microfarad at 475 volts and a 100 microfarad at 300 volts. Right now I'm on the 20 microfarad. So that's good. Light went out. So I'm both testing it and I'm forming it up. So we're good at 100 volts. There's 200. As the light slowly fades, or I should say, the brightness of the light indicates how leaky the cap is. If the light goes out, the leakage is below a threshold that's considered bad. So it went out. And we just keep doing that. Ideally, I get all the way up to 475, and we'll do the other side. But before we bother forming it up anymore, and the fact that it went out is also a very good sign. So it's a split neon bulb. When you charge it, one side lights up, and when you discharge it, the other side lights up. The nature of the what am I trying to say? If the cap was dried out, it had no capacitance left, it might show no leakage, but it wouldn't hold a charge. But we're both charging, fades out, discharging, fades out. Excellent. But let's try testing it before I bother spending a lot of time trying to form it up. But the fact that that light works is a pretty good indicator that it's got some life left. So it's a little low. This thing isn't super precise. It's coming in at around 15 microfarad. It's supposed to be 20, but Alright, and the higher up I go, it should take longer and longer because we're the higher voltages, we got more pressure on the cap, so to speak. It's going to take longer to form up, if it'll form up at all. Why am I putting so much effort into doing the power supply before anything else? Because if the power supply is bad, nothing else is going to work, guaranteed. So that's my advice to you is that's a really good place to start. After that, do the sweep circuits. After that, well, you do video or audio, but definitely power supply and sweep circuits. And just fade it out. And we go up. Well, this is looking very promising on this side. And generally, if one section's good, the other sections have a pretty good chance of being good as well, since it's kind of a shared environment. It's gradually getting dimmer. Okay, I have worked my way all up to about 500 volts. The light went out. Something I didn't do, and often forget to do, is the power factor. So let's dial this in for being open. Yeah, capacitance, it's actually went up a little bit. A little hard to read the scale. 15, it's somewhere between 15 and 20, I think. I'm reading that right. It's an odd scale. Power factor, so we're supposed to adjust this so we get the absolute and best eye opening. And that happens... Actually, this got better too. When I first did it, it was around 10. Now we're down to 4. You'd have to look at specs and whatnot to know what exactly that means, but lower is better. And 4 ain't bad. So I think we are good on that side. So let's put it on 0 before you move the probe leads. These leads can have voltage on them. Let's check the other side. So less voltage and more capacitance. So this tester only goes to 70 microfarad. Yeah, it's old school. But at least we can check for leakage. And this time we just want to go to 300 volts, so we just need to get to that point. More surface area, about 5 times the capacitance to the other side, so I expect it'll take longer, but hey, it went up. But no glow when we discharge. Well, let's see what happens at 2. Well, as I hoped, it was just a matter of letting it sit longer, 5 times the capacitance. Makes sense, it would take longer to form up. There's still just a little hint of a glow occasionally at 300. But now, when I go down to 0, yeah, the other side's lighting up. And it takes quite a while to go out, because it's holding a much larger charge. And as far as testing the capacitance, well, as I said, this only goes up to 70, but right around the top of the range of what this supports, we are getting an eye open, so maybe it's a little low, but I also don't expect this thing is super accurate right at the extreme end of what it's capable of doing. Power factor, it's actually about the same as the other side. Low, it's below 5. So yeah, I'm gonna leave this cap in, and we're gonna see how it works out. Hey, what about the caps that I replaced? Well, here's the one that sure looks like it vented. It doesn't weigh very much. Well, I got that hooked up. So let's see if it has leakage. Hey, no leakage. No leakage, no leakage, no leakage, no leakage. It's a good cap, right? Nah. Light doesn't go on the way up or the way down. Not a good sign. If I go to measure the capacitance value, nothing. Absolutely no change on the eye until I get all the way open to open. It's not a capacitor anymore. The electrolyte vented, dried out. It can't hold charge. It's just an empty can. Totally useless. Alright, I thought you might be interested in knowing what a brand new capacitor tests like. So it's a 47 microfarad, 400 volt, Panasonic, low ESR, long life, 105 degrees C rated electrolytic capacitor. First off, the capacitance is right about where it should be. This thing isn't super accurate, but it's towards the top of the range, around the 40-50 mark. Power factor, it's essentially 0. If I go anywhere up from the bottom, the eye starts to close. So very good power factor. And as far as leakage goes, charge up, charge up, charge up, charge up. That's only rated for 400 volts. That's as far as we're going to go. And when you discharge, nice healthy glow going the other way. Go right back up to 400. Alright, so there you go. Alrighty, got the power supply plugged into the main chassis, replaced the couple caps I had experimented with cutting open. One last thing to do, power. These Zenith porthole sets use an oddball polarized power connector. Now if you're lucky, you still have the back, and if you do, take a couple screws out and this piece comes right out. The original power cord was all crunchy and falling apart, so I cut it off. I'm going to remove the stump of these and attach a new power cord, and we can plug it in. If you don't have one of these, well, power comes in up there. Trace it out, and you can hardwire a power cord in down below, or, well, worst case scenario, tack one right onto those pins that are sticking out. I don't know of any equivalent thing to this. I mean, you could certainly hunt around on eBay or Hamfest parts bins and try to find a connector with the right spacing and right diameter. But I think it's kind of unique to Zenith. Alright, set's plugged in, Variac's turned off. I'm going to turn the set on. Now I'm going to turn the Variac on while I'm monitoring the current draw, and here we go. Pegged up, settled down to about 1.5 amps. It's kind of holding steady there. Turn the voltage a bit. One of the 5U4s is dead. 2 tubes I didn't test. Oh, there we go. Wasn't making good contact in the socket. Looks like all the tubes are lit on the main chassis. So many controls on the front of the set. Alright, so that's cool. We know we can turn it on, at least for the moment, and it's not smoking. I'll turn it off. I'm going to familiarize myself a little bit with the controls on this set. So, let's see, I did print that out. Brightness, I believe, is this guy. So I'll make sure I got that up all the way. I'm going to tilt the chassis down. A little torn because I want to monitor things down below, but also if I don't tilt it down, I can't see what's going on top of the chassis, which I think is more important at this point because I want to check for the presence of high voltage, adjust the ion trap magnet if needed. So yeah, let me rearrange things here. I also get to use my new test speaker setup, Heathkit T2. That's not plugged in, not turned on. I'm just going to drive the voice coil directly from the set. These two guys. And double check too that this does go to the voice coil, not an output transformer. That would be bad to mix up. Set's turned on. Kill the lights. The tubes are lighting up. May hear a crackle out of the speaker this time. I think this is volume. Yeah. Although odd, we're not hearing any crackle out of the speaker. And illumination on the CRT. Let's see if we have any presence of high voltage. A little tough to check with this setup because this cage over the flyback. Nope, no high voltage, I think. No, we do, I think. Unless the illuminations, no, it's coming from my TV. Yeah, looks like we don't. I'm starting to wonder if there's any power actually getting to this set. So I was torn about tipping it down because I want to check voltages, so I got to tip it back the other way. I don't think it's drawing anywhere near as much current as it should be. Well, it's a lot, but the set draws a lot. So we're at a little over 2 amps. and the set is supposed to draw 3 amps. So yeah, we're low. All the tubes that I can see are glowing. Actually, things aren't off by much at all. This is the main power coming in. I got about 290, and according to the Walls Teliade, it should be 305, so within like 5%, 10%. The power systems are getting warm, so, and then the set's started drawing 3, it's up to 2.5 amps. The voltage has been slowly creeping up. Remember, there's some electrolytics in the main chassis, and I imagine they're forming up a bit. But still, absolutely no signs of life, I think. Check the brightness control again. Contrast. There's nothing. Try my voltage trick. Fluorescent bulb. I can do it from the other side of the set now. It's tough to get the horizontal output too, and flyback is there. Recessed. And no. So, I mean, it's not red plating at least, which is good. Although it's a little bit of a blue glow, but that in a beam power tube isn't surprising. Now, it would be surprising if the set just worked and we got a full raster. Sometimes I get lucky, sometimes I don't. But I thought we'd hear a crackle out of the speaker. So, now what? So, as far as restuffing the caps or what am I going to do, jury's still out on that, but I did order up something special. I'll talk more about it when they arrive. It's a new type of cap I've never used before, but even if I just use them as is, if they look like what I think they look like, it should be pretty cool. They're not bright yellow, in other words. I'd like to get something, either audio or video working. I suspect we won't get high voltage until I do at least some work on the horizontal oscillator, horizontal output stages. And as far as the audio amp goes, I'm inclined to start there. I'm a little concerned that maybe the output transformer is toast, so let's check that. I think it's that guy. But it's this guy. Would make way more sense when I have it away from everything else. So here's the speaker wires coming down. Yeah, it looks like they're going right into this. So let's, well, the simplest thing we can do first is check for continuity in the secondary of the audio output transformer. I've been rather lucky and haven't had too many open, but I certainly have had some. Alright, 1 ohm. That's good. That's good. Should be very low on the secondary. Now, primary, where's the primary go? The primary... Oh, where are you? Man, I do not like the way they drew the schematic on the wall. Well, I guess it's the OEM schematic. Bottom right, not where I'm used to seeing the audio output. So between pins 3 and 4 in the 6V6. Okay. Which I'm pretty sure is the tube right next to the transformer. What did I say? 3 and 4. Alright, you guys watch the meter while I probe into this tube socket. Pin 3 and pin 4. Should be like 300 or 400 ohms. 430 ohms. That looks good. That looks good. So why nothing? So I'm not crazy about the schematic, either this or Sam's, because they don't give you any resistance readings on any of the transformers. I'm just going by just general rule of thumb that the primary would be a few hundred ohms, the secondary would be a few ohms, but there are no actual readings on here. Okay, alright, I'll keep poking around. Check some voltages, check the resistance chart. So that's a 6V6 up here, and there's the audio output transformer. I'll tell you what, I'm going to rig up a lead onto the grid of that 6V6, and then I can touch it, and let's see if we get a little hum coming out. So maybe it's just super quiet, so that'd be pin 5. 2, 3, 4, 5. Okay. Hook my test speaker back up. Sit back on. The 6V6 is glowing. There we go. Yeah, you're getting home. Alright, it's just super quiet. It probably means we have a leaky cap that's feeding into the audio and it's just swamping out everything completely, so it's almost acting like the grid of the tube is just grounded. But I'll take it. That's a win. We can get sound out of this set. So, I am going to start doing some work on the horizontal because I want to get a raster, and that would be the stuff in the upper right hand corner. This stuff, I already tacked in one new cap. So what I'm going to do, so I still haven't given up completely on the thought of restuffing these or doing something with them. So I'm going to clip them out. I've saved everything that I've taken out of this set, and I'm going to continue to do so, but I want to do some work up in here. Let's also get a scope. Well, let's do the scope first. Let's get a scope on the grid of the horizontal output tube. I'll tell you, constantly turning everything off and back on, especially the lights, does get annoying, but with all those bright shop lights on, you can't see jack, so that's why I keep turning the lights off. I got my scope on the highest voltage range. The last thing I'm going to do is toast my scope. And we got nothing. So let's go more sensitive. That's not looking good. There's something, but oh, that's weird. There's just a little. It's hard to lock onto. If you guys can see it, there's a little spike dancing around. We should have a sawtooth waveform, so that ain't it. That's not working. Let's just turn it down. So, looks like the horizontal oscillator isn't running, which is a really common problem, so that's where we're going to start. Spent a little bit of time studying the horizontal oscillator circuit. This set's a little different than what I'm used to working on. More commonly, I'll see multi-vibrator circuit, like with both halves of a 6SN7, but this has a 6K6 of all things. There's a horizontal oscillator with a 6AC7 and a 6AL5 forming a discriminator AFC circuit. Then we've got a horizontal discharge tube over here. Well, what I went after was what seemed the most likely problem, which is going to be leaky paper caps. I know, but that's usually what it is. So we've got a .047 here. Bumblebee cap, of course. I replaced it right there. And then I went after this guy, .01. Took me a little bit of time to find it because it's one of these. Looks like a mica cap, right? But brown, black, orange, 10,000 picofarad or .01 microfarad. And I'm guessing 400 volts. The yellow dot. That's a paper cap hiding inside of a mica capacitor looking shell made by Mica Mold. So I replaced those two. That's that guy right there. Let's give it another try, shall we? Scope still in the same place. Watch that on the screen. Dim the lights a little. And power. Do anything? Oh, it's starting to do something. Oh, ho, ho, ho. That's what I'm talking about. And what do you know? We have the inklings of something. So, that's fantastic. That's just by replacing two paper caps that we got, high voltage and full horizontal deflection. Vertical being a disaster does not surprise me at all. Typically, the vertical output cathode bypass cap goes bad, and that's why you only get half the screen being filled, and the top half being a mess is going to be other leaky circuits in the vertical oscillator and vertical output circuits. The linearity looks terrible, super stretched there, super compressed down here. Next, let's try to get that vertical output bypass cap. Let's take a look at the schematic again. Good old Sam's being across 3 pages. It's not on that sheet. It'll be on this sheet. Vertical output, yeah, these are 6V6. Something they use for the audio output. And there we go, 40 microfarad cap across the cathode bias and vertical linearity control. That's going to be a little bit tricky. So there are some electrolytics up here, and I haven't replaced them. 1, 2, 3. So there's also a .1 coupling cap between the oscillator and the output. That is probably causing some problems as well, as is this .047, which is feedback. Use a blocking oscillator transformer for this. So I think I should go after this .01, the .047, and the .1 first. We'll leave the electrolytics alone. There's also one on the primary of the vertical output transformer. The reason I want to leave those alone, well, they're not easy to replace. I could cut a wire and tack one in, but I'm also hoping those caps will form up. And yeah, I could do the same thing I did in the power supply, which is to disconnect them and to use that capacitance tester I used before and try to form them up one by one. I could have done that. Still could do that, but that's really time consuming. So I'm hoping as we go it'll form up on its own by drawing power from the set itself. So anyways, We gotta figure out where those tubes are, those parts. So that's V, geez, I can't even read this. V15 is one of them. Tube chart around here somewhere. Yeah, where'd you go? Come on, I was just looking at it. What I really hate about printing out SAMs is got all these pages. There it is. But they do label the functionality of the tubes, which is nice. So bottom view, there we go. They're right next to each other. It's these two tubes right here. Super easy access. In fact, I've already replaced the 0.1. That was the one that had failed and split open. So I think those are the other two caps I wanted to go after. 0.047, 0.0, and the 0.047 is cracked. So let's get these two guys. Interesting. What's interesting? These three guys. When I was ordering parts, most of them followed the newer numeric system. So we have 0.047, 0.0022, 0.0047. But these were 0.005, which is the old, rounded off way of parts values. These look like mica caps. And I did order up 0.005s. I think I found them. I ordered stuff from Just Radios. But now I'm wondering, are those more paper caps hiding inside mica enclosure, or are those really mica? The reason I say that is that's rather low voltage. Only rated for 200 volts, and I don't even see anywhere near that. So those might be. Generally, if it's 1,000 or below, it's mica, and above 1,000, it'd be paper. But when they're low voltage, it's kind of an important circuit. I wonder. I'll have to test them. See what it comes down to. I replaced those two caps temporarily. And yes, that did improve things considerably. And I suspect if I replaced that cathode bypass cap, that would get it all the way down. But another interesting thing about this set, the way they designed it is, it actually has vertical and horizontal in it. Vertical and horizontal centering controls, that's horizontal, vertical center. So we should be able to move it down. Oh no, that's focus. So that must be vertical center, which is right next to a light bulb. And your screwdriver for that. The way they do this is they put DC bias on the yoke windings. A small amount of current to offset things. Alright, and I can move it up. It's all the way down as far as it can go. When you see controls that are in an extreme like that, it's a good sign that this was a problem developing while the set was still being used. They adjusted things as far as they could to try to get the screen down all the way. I bet it's a leaky cap. Alright, but before I do anything with that, let's try injecting a signal. Let's go for broke. Alright, this is horizontal hold. Some effect, but not enough to lock. Vertical. I think it's this guy. Too hard to tell. Let's try adjusting the contrast. So minimum contrast. Okay, contrast is working right. Let's go maximum. Brightness, maybe. Oh, brightness control doesn't do anything. Oh, no, this is brightness. Oh, yeah, sorry, this is horizontal hold. That doesn't surprise me. Things have drifted off. Face horizontal frequency. Yeah. Oh, there are so many adjustments on this set. So up in here, we've got power volume, contrast, brightness, horizontal hold, horizontal drive, vertical linearity, height, width, horizontal phase, horizontal frequency. You get those last two through holes in chassis. Coils back here. Here we go. Boy, really off. Huh? So they are locked vertically. Looks like we're seeing like 3 images superimposed. The closer you get, the fewer extra images you'll see. 1, 2. It's really hard to get at this slug. That might be as far as I can get. Just didn't seem to be changing anymore. So horizontal phase adjustment, maybe taking that a little bit. Oh, really I need to replace the components that have drifted out of spec. So I'll be making this adjustment again, but it's easy enough to do. Oh, so close.